Welcome to February 6th LeetCode Challenge. Remove duplicates from sorted array 2. Given an integer array nums sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it is impossible to change the length of an array, in some languages you must instead have the results be placed in the first part of the array of nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final results. It does not matter what you leave beyond the first k elements. Return k after placing the final results in the first place of the slots of nums. Do not allocate extra space from another array. You must do this by modifying the input array in place with big of constant extra memory. So this question itself is relatively easy. However, because we can't use another array, we have to modify the input array in place using a constraint of big of constant memory. It gets pretty challenging. So we have a custom judge here. So basically, the algorithm runs the solution based on the assertion such that if you have k equals expected length of the nums, then it passes. So all assertions pass, then the solution will be accepted. And this is some algorithm. So you have input array compared to the correct length, and then the function calls your input array by inserting a specific number, and that's pretty much each language is going to have its own interpreter, its own custom judge. Alright, let's look at an example. So you have the array called nums, and you have a sequence of values in increasing or in non-decreasing order, meaning it could be increasing. So the function itself returns nums in place, so it has the first 5 elements, such that this it would iterate through it and remove any number that basically is a duplicate no more than twice. That has at most twice. So we'll remove one of the ones here, and then remove it somewhere to the end maybe. And it doesn't really matter what's afterwards, but you have the count of 5 being 5 moving duplicates, anything more than 2, essentially. Likewise, you have a non-decreasing order array here, and you want to remove any duplicates leaving at most 2. So that means that you remove a 1, 2 ones actually, from this order. Then you count everything that's remaining. That is at most 2, and then the output is 7, and then you have 2 extra spaces at the end. So that's pretty much the idea behind that, the solution, the question. Nums sorted in non-decreasing order, nums indexed between these two numbers, and nums length is between 1 to 10 to times 10 to the 4, 3 times 10 to the 4. So the approach to this question will probably be best to use a two-pointer type approach. So let's get started. The first thing we're going to do is find the length of nums. So n equals the length of nums. And then next thing we want to do is iterate, find our 2 pointers. So we're going to define them as such. So we're going to define I as 1, and we're going to find another pointer called k, which is 0. So k is going to be the returning k, so after the final results of the first k slots of nums. So basically, we're going to keep track of how many nums are located such that the question is satisfied. And then we have I, such that being the length, the index such is greater than 1, so it's always going to be greater than 1. So these two are going to be our pointers for now. So we're going to start off with iterating through nums, and let's start with a while loop. So while I is less than length of nums, or n I should say, n. What we want to do is if nums at index I is equal to nums at index I minus 1, then we want to do a couple things to it. So this is saying that if we're at the specific index, say here, and if nums minus 1 is the same, so the number before it is the same. That means we have two numbers of the same value in sequence together. So we need to do a couple of things. So we want to check if the number previous, so three numbers behind it, is the same. If it is, we gotta remove one or not counted. So if it's not, then we add our count. So let's do that. So val equals our value. Equals nums at I. And then, so while I plus 1 is less than n and nums at I plus 1, so the index after it, is equal to the value, then what we want to do is increment k. So increment k by 1. We also want to reassign nums at index I plus 1 to be nums at -1 plus 1. So this is basically just adding a placeholder to the last index of the, to the array. And then we do I incremented by 1 as well. So to move on to the next index, because we have a while loop, we need to have it be able to move. And then we also want to increment I again here for the first while loop, and then the second while loop. And then we have, we have the array we need. All we gotta do is, unfortunately, we have to sort again, so sort. And then we have to return n minus k, being the number of the length of the array minus whatever we don't need right here. And let's run this and see if it works. Okay, that would be nums I plus 1 nums. Alright, so far looks good. So obviously space complexity is not using and accepted. Awesome. It's pretty good as well in terms of speed and memory. So space complexity is big O, time complexity is big O of n, because we have to iterate through each value inside the array nums, and we have to use sort algorithm as well. So it's big O of, I believe the sort algorithm is, time complexity for that would be n log n. So that would make, so the sort algorithm here is n log n times, this is running parallel to it, so the whole entire function itself, time complexity is big O of n log n, and then memory is big O of constant memory, or extra space, because storing everything is like k and n values. Alright, that is it. Have a great day, guys.